Hi and welcome back to Geology. I am Miss Sparks, and today we are going to build on to our concepts of what we've already talked about with map making, cartology, and the ideas of what kind of features we can see on it. So previously we've kind of talked about the different types of maps that can be presented, where we can just learn how to read them with using our latitude and longitude, and then practicing our coordinates along our x and our y axes, which is the prime meridian and the equator. Today we're really going to focus in on Earth features, which are just different types of landforms, and pretty much how we can represent those on a map, which is called a topography map. And that's what we're going to talk about today. So grab yourself a piece of paper and a pen or a pencil, and make sure that you get down everything that is underlined today, because it's going to be important. So let's go ahead and move on. So I know this seems like a lot, but there's a lot of definitions, and this is kind of short and sweet today. So topography. So if you brush off your memory from maybe a couple years ago when you took geography, topography was probably introduced to you there, because I know that part of the curriculum in that class is to learn about the different landforms. So you've probably looked at topography maps, which is just, in general, topography is the shape of the land. So we're going to be looking at the different ways in which features can be found on the Earth's surface by looking at a topography map. Not all of them are nice with like a 3D image. Some of them are just a flat surface. So we have to represent them by drawing different types of symbols to kind of help represent what kind of topography is being represented on that map. And so as you can see here, there's all different types. We can have a flat area, sloping, hilly, mountainous, all determined by three different terms, which are going to be really important today: elevation, relief, and landforms. So as we move forward, we're going to kind of talk about each one of these and how they look on a topography map. So the first one is elevation. So if you think about like Kentucky, where we live in Boone County, this is an area that is not at sea level, but clearly we are not as tall as Mount Everest either. So we have somewhat of an elevation. We stand somewhere in between, I think sometimes about 1,000 feet above sea level, and can dip lower and can dip higher depending where we're at. We're kind of at the top of a ridge, where if you travel down to the Ohio River, if you're going down to River Road or Route 8, where the Ohio River is, you're traveling down a slope. And so the elevation changes, and that is just the height above sea level of a point on the Earth's surface. So we're going to be basing a lot of our elevations on sea level, and then trying to figure out what is the point that this land feature is moving up to. So if you think about Hebron, Kentucky, we are kind of sitting up on this ridge area off of the Ohio River. So it goes Ohio River and then up to this ridge type area, and then we're kind of like on this top area where it kind of flattens out a little bit. We do get hilly, clearly, and we'll talk about why that is and what caused parts of the area to be more hilly than the other. But we are kind of in this river type region where there is a lot of elevations that have been depicted due to the flow of the Ohio River. The other term that we're going to talk a lot about today is relief, which is the difference in elevation between the highest and the lowest points. You're not just like, oh, relief, Ms. Sparks isn't giving us any homework today or anything, but this is just the difference. So if you think about mathematically, when you hear the term difference, we're going to do a little bit of subtraction to figure out, let's say that I started at the foot of the Ohio River and I marched all the way up, Tanner's Road. That's going to be quite a difference of elevation. So I would want to find out where I started and where I ended, and how high did I go up or down, just depending on what it is. And we call that the relief, the difference in elevation. So just to give you an idea, this is a picture that you'll probably get used to. We kind of show it quite a bit. So we will talk about all these different land features as we move through this course and really get an idea for the lay of the land. Obviously high elevations are going to be up here in our mountains and volcanic type of regions. And then we move down to our plateaus and basins, and then into the deserts. And then along with that, we can have our much more shallow type areas with our river deltas, our lakes, our valleys, and then even when we get into our hydrous regions with our inlets, our straits, peninsulas, all these different types of features that we will discuss. So landforms. There's all different types, and so we're going to kind of focus on some of the main ones, and then we'll get into talking about the nitty-gritty of them. So this is, once again, geography kind of being brought up in the science class, but sometimes geology and geography and other sciences kind of interlink just a little bit. So landforms is just what it says here, is a feature of topography formed by the process that shapes the Earth's surface, which is going to be some type of rock cycle process, either weathering or erosion, an eruption of some type of material, lava, or we could also look at just pressures and temperature changes. So these landforms are all shaped by that plate tectonic process or the weathering process, and we'll kind of get into more detail about them. All landforms have elevations and relief. They are not all the same. Not every mountain is made the exact same. Not every river is going to flow the exact same. They all are very different, but they have similar features, so we can kind of clump them into different categories. Our landform regions are large areas of land where the topography is similar, and that's what I just kind of said there, is our regions where things are going to be the same. We can all categorize deltas into one type of environment. We can categorize mountains into another. There are some mountains that are growing, and there are some mountains that are shrinking. So we'll even talk a little bit about those different types of landforms. The mountains that you go to get to, like Gatlinburg, Pine Mountain, and parts of the Blue Ridge Mountain, part of the Smoky Mountain chain. All of those are actually mountains that have been eroding down for years and years and years. And when I say years, I mean millions of years. Whereas if we think about Mount Everest in India, that is an area, or that is a region where the mountains are growing. New Zealand, the same thing. That mountain region is growing. So they're still same type of landform regions, but things are changing just ever so slightly with them. Plains. So plains are another type of landform that you can take a look at. And as you can see, I've given 3 different ecosystems in which we can find plains. So we can see them kind of in a desert type of savanna type area, which is going to be, I should have put them in order, which is going to be our interior low relief, but elevations vary. You can see the mountains in the background. So this is a plain that is kind of landlocked just a little bit. You can have our coastal plains, and as you can see, that's just a super flat area. This is normally a representation that the water just keeps receding back, and back. So low elevation of relief. And then finally our Great Plains, which is like Texas and Canada. Once again, landlocked, but clearly a different type of environment. So coastal, interior, and then our Great Plains. Once again, mountain ranges can vary in all different types of shapes and locations and sizes, and what types of rocks are going to be there, and what type of weathering processes are going to be there. So mountains are landforms with high elevation and high relief. They're normally going to be a part of a mountain range. It's not just like bloop, one mountain and then everything else is a plain. There's normally a ridge of them, and that has to do with something with plate tectonics too that we'll talk about. Mountain ranges are normally part of the system, and they are also part of a belt, which is normally that conduction or subduction belt, where you have the oceanic crust going underneath the continental crust, and we'll talk about what that is. But mountains are a part of that subduction. With you have 2 different plates running into each other, which are continental. We'll talk about that. Plateaus are landforms that have high elevations and have level surfaces. So meaning that they have been moved or pushed up and then kind of been eroded down to have like almost like a mohawk or a flat top type of region to it. So a landform that has high elevation and then it levels off. Rarely perfect smoothed on top, but from a distance you can kind of see right here. This looks clearly, you can see that this area here is been pushed up and then this has been eroded down. Or something has caused flat here and cut these rocks down. We'll talk about why. So just to kind of give you an idea, once again, just bringing up some of the terms that we've already talked about and we will discuss a little bit more, is the lithosphere, atmosphere, hydrosphere, and biosphere are spheres that kind of help make up the regions and landforms that we are going to see. So I'm not going to read over those. We've already kind of gone over them. And then here's just some review questions to see if you can answer them correctly for comprehension. So I hope this was helpful.